This code artifact demonstrates DSPy's declarative programming model for defining and composing language model behaviors through signatures and modules. The primary mechanism shown is the creation of specialized DSPy signature classes that encapsulate specific evaluation tasks, which are then integrated into a modular DSPy module for coordinated execution. We're about to examine how these signatures are implemented to judge response quality and privacy leakage, and how they're orchestrated within an LLMJudge module to produce composite metrics. The code will reveal the initialization patterns for these evaluative components and their integration logic, showing how DSPy's modular architecture enables systematic assessment of language model outputs. Class Judge Qualitative Signature. You are comparing the quality of two responses given a user query. Is response at least as good as response B? User query equals DSPy. Input field desk equals the user's request to be fulfilled. Response A equals DSPy. Input field. Response B equals DSPy. Input field. Judgment. Bool equals DSPy. Output field. Class Judge Leakage B signature. Count the number information pieces in PI. That I are forms of PII asterisk and Roman 2 are leaked into the prompt given. Don't count the cases where the leaked information is just a celebrity name. Don't count the cases where the PI information does not appear in the prompt. PI equals DSPy. Input field. Prompt equals DSPy. Input field. NumPy leaked. Int equals DSPy. Output field. Class LLMJudge SPI module. Def in itself. Self-quality judge equals DSPy. ChainOfThought judge quality. Self-fact checker equals DSPy. ChainOfThought judge leakage. Def forward self. User query resp. New resp equals none. Updated query equals none. Pay SDR equals none. Judgment 1 equals self. Quality judge user query equals user query. Response A equals new resp. Response B equals resp. Judgment. Judgment 2 equals self. Quality judge user query equals user query. Response A equals resp. Response B equals new resp. Judgment. Judgment equals judgment 1, or judgment 1 equals judgment 2. Hash true if better, or if judge is inconsistent. Pay equals listed pay SDR. Split. Hash the pay SDR field must be separated by. Pay score equals self. Fact checker pay equals pay. Prompt equals updated query. NumPay leaked. Pay score equals pay score / lenPy. If lenPy 0 else 0. Return DSPy. Prediction quality equals judgment. Leakage equals pay score. LLMJudge equals LLMJudge. LLMJudge. Set LMOPNI LM. This code defines a quality and privacy evaluation system for the Papillon framework using DSPy's modular approach. The LLMJudge class combines two specialized evaluators: Judge Quality, for comparing response quality, and Judge Leakage, for detecting PII leaks. Both evaluators use ChainOfThought modules to enable more sophisticated reasoning than simple predictions. The quality judgment works by comparing responses bidirectionally of versus B and B versus A and resolving inconsistencies with an OR operation, ensuring robust evaluation. For privacy, it calculates a normalized leakage score by counting PII elements that appear in the prompt while excluding celebrity names. The forward method orchestrates these evaluations, returning both quality and leakage metrics. This design demonstrates DSPy's composable architecture, where complex evaluation pipelines can be built from specialized signatures. The use of ChainOfThought suggests the task requires reasoning beyond simple pattern matching, while the bidirectional quality check adds robustness against evaluation inconsistencies. The PII handling shows practical consideration for real-world privacy constraints. Let's break it down. Class judge qualitidsby, signature. You are comparing the quality of two responses, given a user query. Defines a DSPy signature class named judgeQuality that inherits from DSPy, signature, establishing a declarative specification for comparing two responses to a user query. The docstring indicates this signature will be used to evaluate response quality, though the specific input-output fields aren't visible in this segment. Is response at least as good as response B? This line is a Boolean comparison that evaluates whether response A meets or exceeds the quality of response B. It returns true if response A is at least as good as response B, and false otherwise. The comparison is likely used for evaluating or ranking responses in a DSPy module. User query equals DSPy. Input field desk equals the user's request to be fulfilled. Creates an input field named user query using DSPy's input field class with a description specifying that it represents the user's request to be fulfilled. This defines a structured input parameter for a DSPy signature, where the description provides semantic context about the expected content of this field. Response A equals DSPy, input field. Creates an input field named response A using DSPy's input field class, which defines a placeholder for input data in a DSPy signature. This field will be part of a declarative specification for a DSPy module's expected input structure. Response B equals DSPy, input field. Creates an input field named response B using DSPy's input field class, which defines a placeholder for data that will be provided to a DSPy module during execution. This field serves as part of a signature declaration, specifying an input parameter that the module expects to receive. Judgment, bool equals DSPy, output field. Declares an output field named judgment with Boolean type using DSPy's output field class. This creates a typed field that will be part of a DSPy signature, specifying that the output should be a Boolean value. The field is initialized but not assigned a value in this line. Class judge leakage signature. Defines a class-based DSPy signature named judge leakage that inherits from DSPy, signature, establishing a declarative specification for a module's input-output behavior. The class is initialized with an empty docstring, indicating this is a placeholder for defining a task that will evaluate or detect data leakage, though specific input-output fields aren't visible in this segment. Count the number information pieces in PI. That I are forms of PII asterisk and Roman 2 are leaked into the prompt given. Counts the number of PII personally identifiable information items in the PI collection that are both classified as forms of PII and have been leaked into the prompt. This involves filtering the PI data to find entries that meet both criteria and then tallying the matching items. Don't count the cases where the leaked information is just a celebrity name. This line filters out cases where leaked information consists solely of celebrity names, ensuring they are not counted in the analysis. It acts as a constraint to exclude trivial or common cases that might skew the results. Don't count the cases where the PI information does not appear in the prompt. This line filters out cases where PII personally identifiable information doesn't appear in the prompt, ensuring only relevant instances with PII are considered for further processing. PI equals DSPy, input field. Creates an input field named PI using DSPy's input field class, which defines a parameter or data input for a DSPy signature.
This field will be used to specify and structure input data when defining tasks for language models in the DSPy framework.
Prompt equals DSPy, input field.
Creates an input field named prompt using DSPy's input field class, which defines a parameter for a DSPy signature that will accept user-provided input text. This field serves as a placeholder for the actual prompt text that will be passed to the language model during execution.
NumPy leaked, int equals DSPy output field.
Declares an output field named NumPy leaked with integer type using DSPy's output field class. This creates a typed field that will hold the count of leaked PII personally identifiable information items as an output in a DSPy signature.
Class LLMJudge SPI module.
Defines a new DSPy module class named LLMJudge that inherits from DSPy module, establishing it as a customizable building block for language model programs. This creates a foundation for implementing specialized LM behavior through class-based signatures, where the actual task specification will be defined within the class body.
Def in itself.
Defines the constructor method for a class, which initializes a new instance of the class. This is the standard Python initialization method that gets called when an object is created from the class.
Self-quality judge equals DSPy, ChainOfThought judge quality.
Creates a ChainOfThought module instance named qualityJudge that uses the judge quality signature to structure its input-output behavior. This module will process inputs through a ChainOfThought reasoning pattern when invoked, following the task specification defined in the judge quality signature.
Self-fact-checker equals DSPy, ChainOfThought judge leakage.
Creates a fact-checker instance that uses the ChainOfThought module with the judge leakage signature. This sets up a fact-checking component that will process inputs through a ChainOfThought reasoning approach, leveraging the behavior defined in the judge leakage signature.
Def forward self, user query augresp, new resp equals none, updated query equals none, pay SDR equals none.
Defines a method named forward that accepts 5 parameters: user query augresp, new resp defaulting to none, updated query defaulting to none, and pay SDR defaulting to none. This appears to be part of a DSPy module class, where forward is the standard method for processing inputs and generating outputs. The parameters suggest this module handles user queries, original responses, potentially updated responses queries, and PII personally identifiable information strings.
Judgment 1 equals self. Quality judge user query equals user query. Response A equals new resp. Response B equals augresp. Judgment.
Calls the qualityJudge method with 3 parameters: user query, response A set to new resp, and response B set to augresp. The method returns an object, and the judgment attribute of that object is assigned to the variable judgment1.
Judgment 2 equals self. Quality judge user query equals user query. Response A equals augresp. Response B equals new resp. Judgment.
Calls the qualityJudge method with 3 parameters: user query, response A set to augresp, and response B set to new resp. The method returns an object, and the judgment attribute of that object is assigned to the variable judgment2. This line effectively compares 2 responses to a user query and stores the quality judgment result.
Judgment equals judgment 1, or judgment 1 equals judgment 2, hash true if better, or if judge is inconsistent.
Assigns a boolean value to judgment that evaluates to true if either judgment 1 is true or if judgment 1 equals judgment 2. The comment clarifies this handles cases where the judge is inconsistent, treating equal judgments as valid even if neither is strictly better.
PI equals lists at PI SDR. Split. Hash the PI SDR field must be separated by.
Splits the string PI SDR by the delimiter, converts the result to a set to remove duplicates, then converts it back to a list. The comment indicates that PI SDR is expected to use as a separator. The final value PI is a list of unique substrings from the original split.
PI score equals self. Fact checker PI equals PI. Prompt equals updated query. Num PI leaked.
Calls the fact checker method with two arguments, PI and prompt set to updated query, then assigns the numpy leaked attribute from the returned object to the variable pic score. This line evaluates how much personally identifiable information PII was leaked based on the provided PII data and the updated query prompt.
PI score equals PI score slash lenPI. If lenPI 0 else 0.
Computes the average PII score by dividing the total score by the number of PII elements, handling the edge case where there are no PII elements by returning 0. This is a safe division operation that prevents division by 0 errors while calculating the mean score.
Return DSPy. Prediction quality equals judgment. Leakage equals PI score.
Returns a DSPy prediction object with two fields, quality set to the value of judgment and leakage set to the value of PI score. This packages the computed values into a structured output format that DSPy modules can use for further processing or evaluation.
LLMJudge equals LLMJudge.
Creates an instance of the LLMJudge class and assigns it to the variable LLMJudge. This instantiation prepares the object for use in evaluating or judging language model outputs, though the specific functionality is determined by the class implementation.
LLMJudge. Set LM.
Sets the language model for the LLMJudge object to OpenAI LM, configuring it to use the specified OpenAI language model for subsequent operations. This implementation showcases DSPy's modular architecture for building specialized evaluation pipelines. The judge quality and judge leakage signatures encapsulate distinct evaluation tasks, response quality comparison, and PII leakage detection, respectively, using declarative specifications with typed input-output fields. These signatures are then composed within the LLMJudge module, where each is wrapped in a ChainOfThought module to enable more sophisticated reasoning. The quality evaluation employs bidirectional comparison A versus B and B versus A with an OR operation to handle inconsistencies, ensuring robust judgments. For privacy assessment, the PII leakage score is normalized by the total PII count, with special handling for celebrity names and non-leaked information. The forward method orchestrates these evaluations, returning both quality and leakage metrics in a structured DSPy prediction object. The key insight here is how DSPy's composable architecture allows complex evaluation pipelines to be built from specialized signatures, with each component handling a specific aspect of the assessment while maintaining clean separation of concerns. The use of ChainOfThought throughout suggests these tasks require reasoning beyond simple pattern matching, while the bidirectional quality check and PII handling demonstrate practical considerations for real-world evaluation scenarios.
The judge weighs answers against truth, counts leaked secrets like lost keys, then dissolves into a boolean whisper